welcome back to the channel. So in today's Sunday quick builds, we're going to do a simple LED flasher circuit. This is one that I designed on every circuit, as I do with a lot of different circuits that I make. I'm trying to tilt this so you guys don't get glare so bad. And I've got the camera in down low and close with my macro lens on, so hopefully you guys can see what's going on. We're going to use a couple of these NPN 2N 2222 transistors. We're going to use a couple of different resistors and capacitors to make these things flash with just a simple 5-volt USB. So the first thing that you want to do is you want to install these in the obverse of one another. And when I say these, the transistors. So we're going to install him this way, and then we're going to flare the legs out on our other one. Now all of these connections are going to be, all the components are going to be topside, and then we'll put all of the wiring down under the board. This circuit, like I said, is incredibly easy to make. I'm going to tell you what, I'll pull up on, see if you guys can get a view on my screen here of the circuit. I'm going to zoom out just a little bit and come down. So this is our basic circuit, okay? Just our simple, never mind this portion right over here. Just a simple basic circuit. Carrying 5 volts up and around, hitting a resistor, coming down to a LED, and then tying across to a transistor that crosses over between the two with a couple capacitors in line. And those capacitors, as they charge and discharge, will flash our LEDs. So, and I'm going to zoom in on this so I can see. The first thing that we're going to need is a couple of, we're going to need a couple of resistors. So we're going to need some 68 ohm, give or take, resistors. Looks like we're going to need, and just double check, 2 68 ohm resistors. Now these don't have to be perfect. You don't have to get these exact. Close enough, because the flashing, the time on, time off for these is long enough that it won't really matter. So we're going to set these two aside, and we're going to go ahead and install them. So go away, shoe fly, don't bother me. So our first resistor is going to come right up here off this top side, because he's going to tie to main power, okay? And then off of our resistor, hey mister, it's a resistor. And what I've done is I've kind of folded the leg over and installed him that way, just to make life a little bit easier on us. Just to make life a little bit easier on us. We're going to do the same thing with the other. Let's see what we're going to install them this way instead of the other way. Okay. So I've installed those that way, because the next thing that we're going to drop in, we're going to come off of the main, we're going to branch a main line all the way across on this high side. And I need, I believe it's a 15 ohm and a 20 ohm resistor. Is it, oh, 20K ohm. A 15K and a 20K. And again, these don't have to be exactly perfect. Get as close as you can. So I've got an 18 and a 22. I don't have any 20s. So the 15 obviously is fine. For the 20K resistor, it can be either the 18 or the 22. Just close enough is good enough. These are not going to see a lot of heat, and they're not going to see a lot of amperage. Very little wattage on them. So because of that, because they're so low, it's nothing that we have to worry about. I'm probably going to go ahead and go with a 22 ohm. What I'm going to do though is I'm going to plug that in to my every circuit and just make sure that works the way that he should. Yep, that should work just fine. Okay. So our 15 ohm resistor is going to go one or two spaces over. And then our 22 ohm resistor is going to go one or two spaces over. Before the 68 ohm. Oh no, a 22 ohm won't work. Let me switch that because it's blowing my LED on here. Let me switch him to an 18 and see what that gets us. 18 ohm will make it work. So we'll go back to the 18. And these are at 1%. These are, and I say at 1%, these are pretty decent resistors. They're not the greatest resistor in the world, but they'll certainly get the job done. Well, I said that. Is that blowing our LED too? Looks like it's blowing it every once in a while. Let's drop down or go up. Let's go up. So it looks like it's going to have to be a 15 kilo ohm as well. That makes life simple for us. So the good thing is the good thing about this particular app, as I've mentioned before, is you can really get in here and play around with things and adjust different things on the app to make the circuit do all sorts of unique things. You can check voltages, you can check ohms, you can check what the current is, what the milliamp draw is. You check all those things, which is really handy. So we're going to install him a couple of spaces over as well, just like that. And that's going to be it for our resistors. Now we've got to get a couple of LEDs. And the color of LEDs we use is kind of irrelevant. It doesn't really matter. I'm just going to grab whatever comes out of the box first. So, no, we're not using that. I'm not using that. I would prefer a color of some sort. There's a 5mm green. I don't know that I want to go with 5mm. I prefer a 3mm LED on here. That's white. That's 5mm. I really should probably go with a better. Okay, there's an orange. We'll use an orange. We'll use a purple. Perfect. So these are 3.4 volt LEDs, 20 milliamps. it's a UV or a purple. It doesn't give us, it just says UV or purple, but it doesn't really give us a wavelength on them, so I'm not super concerned about it. The wavelengths should not matter too much on these. That is a 2 to 2.2 volt on our orange. We're not going to use him. I want to try to stick in our 3 volt range. We'll use blue. Blue it is. Now we could up the resistor size on our 68 ohm resistors. We could up those, and that would decrease the voltage to our. So this is our blue one. Let me put him over here. Okay, so starting on this side. Sorry. If we increase the voltage or the ohms from 68 to like 98 or something, it would decrease the voltage going to our resistor. Okay. So what we're going to do is we're going to come down off of our LED right beside this guy. We're going to drop him in. And I'm just watching my circuit to make sure it is blowing this LED occasionally still. Let me go up here. I'll go from a 68. Okay, that's what we're going to do. We're going to switch these two resistors out on this guy. So what we can do and what we're going to do is we're going to swap these resistors out, these first two 68s, to 80 ohm, give or take, 80 or more, and that will drop our voltage down. Maybe we'll have to go to 100 ohm. Let's see what happens if I go to 100 ohm. Okay, that seems to work just fine. Since that's my nearest step that I've got without going to a SMD, which I could go to, and I may go to a SMD sized, but they're not going to take as much abuse, so we'll stick with these guys right here. We'll just go with the 100 ohms. The speed of the flash doesn't really matter. It's just kind of building this a little bit, and I can play around with the capacitor somewhat. And that's the good thing about this, right? That doesn't help. I put it up and didn't get the resistor that I wanted out at all. I put the other ones up and didn't get the hundreds out. That's the great thing about this simple circuit is it is a very, very, very simple circuit. But it's cool to play with, and it's cool to watch. It's cool for you guys to build. They're super quick, super easy to make, and you can kind of play around with it. You can increase if you want your light on time to be a little bit longer or a little bit less. You can increase or decrease your capacitance rating on your capacitors, swapping those guys out. You can do all sorts of cool things. I just did this way because it was quick and easy. So again, swapping out the 68s, we'll go with 100 ohm resistors. Sorry about giving you the wrong information. As I began to play with the circuit, I changed my mind based on what my circuit was going to do. Okay. All right, and so for our next, now we've got our LED in line. Our next LED is going to go in line. In line, positive leg up, same as the last one. Negative leg down, and then we're going to go to our capacitors. Now on our capacitors, this side needs a 10 microfarad. Voltage is kind of irrelevant. As long as you're less than 5 volts, you'll be fine. And our other side, it's a 50 microfarad. And this is going to offset 50. Well, let me key in a 47 and see what happens, since that's what I've got. Just going to slow down our flash. 47 microfarad. Again, 25 volts is fine if that's all. If that's what you got, use that. You could go as low as 10 if you wanted. But what I've got handy is a 25, and so that's what we're going to use. The good thing is it'll keep our circuit nice and cool, so to speak. So off of our LED, positive side on this needs to be closest to our LED. Oh, nope, that's wrong. This is our 10. This side over here is our 10 microfarad. Negative needs to face in towards the inside of the board. And on this side is our 47 microfarad, just like so. Let's fire our soldering iron up real quick, and we're going to tack these components in place just real quick and easy. I'm going to flip this board over so I can start bending a few legs around. So that nothing falls out. Like that. So that nothing falls out like our LED just did. That one almost did too. Cool. When I say cool, I definitely don't mean that was cool. That was actually terrible. So is life, I guess. Okay. Once our soldering iron gets up to temp, we're going to tack these guys all in place. And then what we're going to do is, and we're going to do just a quick dirty tack in place job on these. Nothing beautiful at all. clip these legs off as we come to them. I will put the jumpers. Actually, I'm going to go ahead and fold him this way, clip him off. We will tie our jumpers in here in just a little bit to get all of our components, our circuit components, across to each other. But for now, we'll just clip these guys off as we tack them in place. Now the good thing about these little maker boards, I call them maker boards, the good thing about them is that you can pretty much, it's just a bunch of vias plated through, kind of, and I say in series, they're not really necessarily in series, but it's just kind of a bunch of vias that are plated through, and so you can pretty much make whatever you want on them. Okay, guys, give me just 1 second. Okay, guys, sorry about that. The wife was getting ready to leave to go out. I'd like to send her out for a few hours, kind of during some point during the week. She teaches kids all day, and the last thing she needs is to be hemmed up in the house all the time. Where was I? So what we're going to do is just tie all of our LEDs to the resistor above them. Go ahead and tie these resistors that are in line. That are on our main leg here. There we go. So this series of doing things is not about making the prettiest, most beautiful things in the world. It's merely about showing you guys how to make basic circuits for things. We're not trying to build the world's most perfect circuits. Somebody come let the dog out. We're not trying to build the world's most beautiful circuits here. We're just trying to build some circuits and show you guys how to do things. And that should be our LED lights. Now we've just got to deal with our capacitors, which are capacitor on our front side. Let me make sure I did that right. Yeah. Okay. So after our LED, so our one side of our LED ties to our 100 ohm capacitor, which is tied off of the main. The second side of our LED is going to tie to the positive side of our capacitor. So let me make sure he's tied in on the proper side. This would be the positive side here. He should come this way. I'm going to tack him in place real quick. To the other side of our LED. Now, the negative side of our capacitor should come up here to the output side of our 15 kilo ohm resistor. So he's going to come all the way up here. Okay, just like that. Now, from here, we're going to have 3 legs on our transistor. And I'm going to tell you what I'm going to do. I'm going to go ahead and solder in our middle leg, just the middle, on both transistors. Just like that, so that he stays put. Now, our other capacitor should come right here. We're going to tack him in place real quick like. If you guys remember from the other side of this, one of our capacitor legs will come straight off of our LED diode. The other capacitor leg will tie to our 15 kilo ohm resistor on this side. We are just about to the point of wrapping this guy up. Now, transistors, how do they connect? So the output on our transistors all go to ground, okay? So we're going to fold him over, and we're going to fold him over this way. Ground's going to come in this way. All right, our input side of our transistor is going to go to the positive side of our capacitor. Okay, which means he's going to have to come this way, and then we'll have to put a little jumper in, okay, on the positive side. And he's going to have to come, which side's positive? Okay, that's easy enough. So he can actually just come straight over here. Cool. make sure that I've done this properly. Okay guys, we got our wire all soldered up on this side. So again, we're taking our positive in on one and our negative out on the other. Okay, let's flip him over, and I'll tell you what, I'm going to kill some of these lights. At least one or two of them here. Make brighter, kill, turn off. Get him in shot for you. There we go. And let's plug him up, see what happens. We'll give him the smoke test. There we go. Simple flashing circuit based on capacitance of our... Sorry, I'm just feeling around, making sure nothing's getting warm. No. Now, if anybody was curious, according to my USB plug-in multi-hub thing that does voltage and amperage, this is actually drawing 0 watts. So nears makes no difference, 0. And if I had to say why, it's probably drawing 0 watts because the flash is so fast and everything's running. All we're doing is charging a capacitor. Really, that's all we're doing, and so that's why. But if you want to do that, and you can expound on this, you can absolutely expound and grow on this and make these things flash in any number of ways. But as a simple circuit, that is really all there is to it. Should really clean up that big blob of solder right there, huh? I just left sticking up. I think that happened when I there we go. Huge blob of solder sticking out. So you can adjust the speed of this without having to do anything special, without having to use any sort of a timer circuit, without having to use any sort of a 555 timer, 888 timer, or without having to use a clock on it or at all. You can adjust the timing and how long that these LEDs each stay on for. You can adjust that by the size of the capacitors, okay? By increasing and decreasing those. You could actually make this an even tick, 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 tick by putting the same size capacitor over here, whereas this is a 10 microfarad and this is a 25. If you made them both 25s or both 10s, they would flash really fast. The lower the capacitor, the faster they're going to flash. The larger the capacitor, the longer they're going to stay on before they discharge. So what's happening here is power is coming in, traveling down our circuit, okay? Traveling down our circuit. And as power gets down our circuit, it's coming down, hitting our LED, igniting our LED, sending power back to charge our capacitor. This capacitor is charging up and allowing the emitter and collector on the two transistors to alternate back and forth. So this is literally what is keeping this LED lit over here is the capacitance in this circuit, okay? That's what's keeping it lit. And it's doing that because as the voltage on our capacitor drops off to 0, it is telling this transistor to fire up, okay? Which is completing this circuit and firing that light. As this capacitor drains, okay, the obverse is happening. As this capacitor fills, okay, and waits on this one. It fires this light, and when the capacitor is drained, it sends a negative back across here, closes or opens the circuit up, which tells this to open the ground up and bring current back through. Okay, returning to ground. Simple circuit, simple to make. Listen, guys, I hope that you enjoyed this video. I hope you learned something. I hope you saw just how easy this is to make. Again, super simple circuit, really cool to have fun with. You can add these, you can change this up. The simple thing to remember is that your capacitor has to work along with your transistor. Okay, that's the part to remember here. They can't fight each other. They have to work together. And as long as you take your time, everything should come out great. Anyways, I appreciate you guys watching. I hope you learned something today. I hope you liked the video. If you liked it, hit the subscribe button. Make sure you give me a thumbs up. If you didn't like it, give me a thumbs down and don't subscribe. Or subscribe and see if I get any better. That's always a good thing. Leave a comment down below. Tell me what you thought of the video. Tell me what you guys want to see me make next. And we will catch you guys on the next one. Thanks so much for watching.